Hello dear student, our today's topic name is Oxidative Addition Mechanism from paper CHI 330 section 2nd. A recapitulation of our previous lecture is Introduction of Oxidative Addition, Types of Oxidative Addition and Factor Affecting Oxidative Addition. All these 3 points we learned in our previous lecture. So, move towards our today's topic, that is content of our today's lecture is Mechanism of Oxidative Addition Reaction. Okay. Now see the mechanism of oxidative addition reaction, because if we want to find stereochemistry of product, we must know the mechanism of that reaction. That's why we learn this mechanism of oxidative addition reaction. Okay. These concerted mechanism, SN2 mechanism, radical mechanism and ionic mechanism, these four are the types of mechanism of oxidative addition reaction. Okay. Out of these four, these first two, this concerted mechanism and SN2 mechanism are important. Okay. We will learn one by one. Okay. First move toward concerted mechanism. This concerted mechanism is three-centered associative reaction. In this mechanism, the incoming ligand first bind as a sigma complex. Okay. Then it undergo bond breaking as a result of strong back donation from the metal into a sigma star orbital. Okay. So, first sigma complex is formed. Okay. And then bond is break and the electron density is donating from metal to the sigma star orbital of ligand. Okay. So, see here the general example. Okay. LNM plus this AB bond. Okay. See here, in this reaction, this AB molecule is added over this LN M and new sigma bond, new sigma complex is formed. Okay. After that there is a bond is after that these bond are break and the electron density is donating from metal to the sigma star orbital of ligand is observed. Okay. So, see here metal is in zero oxidation state, here also metal is in zero oxidation state and here the oxidation state is increased by 2 unit. Okay. Now, this is a general example. Then next is addition of H2 to the viscose complex. Okay. So, see here this carbonyl and chloride are trans to each other and there is a 2-triphosphene here. Triphosphene ligand which is in square planar geometry and the electron here square planar geometry and which has 16 electron count and iridium is in first oxidation state and it has a trans geometry. Okay. Now, H2 is added to this complex. Now, this H2 is added in this complex. Now, see, now sigma bond is formed. Okay, see here, new sigma bond is formed by donation of electron and electron count is here again 18 electron count and this complex have trigonal bipyramidal geometry but iridium is in +1 oxidation state. Okay. Then this complex is broken and new two bonds are formed. Okay, means this bond is break and new two bonds are formed. Okay, see here, these new two bonds are formed. Now we can see here this trans bond are cis here. Okay, in this way trans geometry is changed to cis geometry. This trans geometry is changed to cis geometry. And cis dihydride complex is formed. Okay, see here, this cis dihydride complex is formed. Electron count is 18 electron. Okay, means conversion of 16 electron to 18 electron. Okay, and it has 3 oxidation state. Means two things are changed here, three things. Trans is changed to cis, 16 electron count is changed to 18 electron count, and oxidation state is from iridium first to iridium third. Okay. Okay. Means first see here, we will see here this carbonyl and chloride are trans to each other. Okay, it has these two are triphosphine ligand. It has square planar geometry, 16 electron count. Iridium is in first oxidation state and it has trans geometry. Okay, when we add this H2, then the new sigma bond is formed. Okay, new sigma bond is formed by donation of 2 electron. Okay, and electron count is here 18 electron. Okay, means electron count is increases, and these complex have trigonal bipyramidal geometry, but here iridium is again means no change in oxidation state. Iridium is here in +1 oxidation state. Then this complex is broken. Okay, means this complex is broken and new two bonds are formed. Now we can see here these trans bonds are converted into a cis bond. See here, these two cis bonds are formed. In this way, trans geometry is changed to cis geometry and cis dihydride complex is formed. Okay, and first the geometry is trans, then geometry is going to change, that is cis. Electron count is here 16 electron, here electron count is 18 electron, and oxidation state, first oxidation state is first, then oxidation state is third. Okay, this is the addition of H2 to the viscous complex. Now addition of O2 to the viscous complex. Okay, now see here, O2 also a non-polar ligand. Okay, see here, iridium first reduce O2 to O2 minus. Okay, peroxide ion then coordinates to metal iridium is in third oxidation state. Okay, O2 is non-polar ligand and here iridium is in first oxidation state, will be reduced to O2 minus. Okay, that is peroxide ion, and then peroxide, that is peroxide ion, means this is peroxide ion. Okay, to metal iridium third. Now see the general reaction. Okay, now see the general reaction. This is viscous complex. Here iridium is in first oxidation state and geometry is trans. Okay, now addition of O2. Then two are triphosphine ligand. Okay, these are the ligands, two ligands. And when O2 is react with this complex, when O2 is react with this complex, the sigma complex is formed. This is the first step. Okay, and then carbonyl and chlorine are earlier trans to each other, that are bent and take a cis geometry. Okay, means here the geometry is trans, and when we add O2, then geometry is changed from cis to trans to cis. Okay, now the next step is formation of two new bond. Okay, between two oxygen and iridium, and this sigma bond is break. Okay, this sigma bond is break and two new bond are formed. In this way octahedral complex is formed. Here this complex is octahedral complex is formed. Iridium comes in third oxidation state and coordination number is also increased by 2 units, but first trans complex is now cis complex. Okay. Now when non-polar ligand are added, the oxidation is formed and it form a cis complex. Okay, this is a addition of O2 to the viscous complex. Here also iridium is in first oxidation state, in last iridium is in third oxidation state. First geometry is trans, then it's changed from trans to cis. Now move toward second mechanism, that is SN2 mechanism. Okay, it is found in polar ligands such as alkyl halides. Okay, this mechanism found in two steps. Okay, for example, uh, now example of this mechanism is addition of CH3I to viscous complex. Okay, this is alkyl halide. This is a general reaction. Viscous compound has square planar geometry and it has 16 electron count, and we said that this carbonyl and chloride are trans to each other, and when we add methyl iodide is treated with this first complex, the methyl ion will be added to this complex. As a result, this type of complex is formed. Okay, when we add methyl, then this type of complex is formed. Okay, after methyl ion is formed, and this complex has a result, they form that have this complex that have 16 electron count, and iridium is in third oxidation state, means iridium first is oxidized to iridium third. Okay, now the electron count is 16 electron, that is constant. Why? Because methyl ion is in zero oxidation, zero electron. Methyl has 0 electron ligand, because it is a positive ion and it does not donate electrons, but oxidation state is increased here by 2 unit, and in next step this iodide ion attach from trans side and this step is faster. Okay, means this iodide is added from trans site. Okay, and the trans product is formed and it has 18 electron count because the iodide ion is 2 electron donor, that's why oxidation state increased by 2 unit. Okay, see here electron count is not increased because methyl is positive ion, that's why the electron count is remain constant, but oxidation state is here, oxidation state is increased by 2 unit. Okay, after this mechanism or this step, we add this iodide from trans site. Okay, and we get this complex. Okay, because we add this iodide from trans side, that's why we get here a trans product. Okay, and see here electron count in first complex is 16, that electron count in last complex is increased by 2 unit, that is 16 to 18 electron. Oxidation state from first to third, which is also increased by 2 unit, and cis to trans geometry. Okay, this is SN2 mechanism. Okay, in this SN2 mechanism we use these alkyl halides, very simple. Okay, in our today's lecture we see here concerted mechanism, SN2 mechanism. Okay, now our today's assignment. So first question of our assignment is explain in detail mechanism of oxidative addition reaction. This is our today's assignment. Okay, so thank you dear students.